Okay, everybody, I'll try to do words, pictures, and formulas. The words will be in red, formulas in gray. Okay, so part A, what is a linear combination? First, I'll just do an example. And so my example is, let's say, 3 times the vector 2, 3, plus the scalar 5 times the vector -1, 1, times, or plus the scalar -1 times the vector 3, 7. Okay, I could keep going, plus as many as I want. But let's stop it at 3. And then this would be, I could actually compute this. And what would I get? I'd get, well, maybe I'll compute it down here. How about 6, 9? Okay, that's a vector. So I multiplied that vector by 3. Now I'm going to multiply this vector by 5. Now I'm going to multiply this vector by -1. And now I'm not done, because now I can add these vectors. The only things we can do are scale vectors and then add them. So let's do these. Actually, I can do them all at once. The top will be, I think that's right. And then the bottom number will be, I think that's right. Okay, so that's an example. And I put in words, here's an example. And now I'm going to say, a linear combination is a weighted or scaled sum means I'm adding vectors, sum of vectors. That's it. Okay, done with A. Part B. How is any v in R2 a linear combination of these special vectors? Okay, so what do I say? Well, first I'll draw a picture, actually. This is the vector e1, which is just a special name for the vector 1, 0, which I could also write as a column, 1, 0. And then this vector, it has a special name. It's called e2, and it's the vector 0, 1, which I could write like that, either way. Okay, and then I'll continue with my picture. So this vector right here is actually the vector 4, 2, and maybe I better put that in gray, because it's a formula now. 4, 2 is equal to 4 times e1 plus 2 times e2, which, these have names, so I could use the names. Okay. So now after a picture and formula, I can say in words, any v in R2 has two numbers or components or pieces in the directions e1 and e2. And then I'll put the formula is that if v is some number like 4, 2, then that's equal to v1 e1 plus v2 e2, where the vi are just real numbers like 4 and 2. Okay, how about C? How is v equals 4, -3 pi a linear combination of e1, e2, e3? So these are very special vectors. So for part C, I'll just say 4, -3 pi equals 4e1 minus 3e2 plus pi E3, where E1, E2, E3 are now in three-dimensional space, meaning I could also write this as, like, that's what E1 means. That's what E2 means. And that's what E3 means. And then, in a picture, they're sort of, well, usually I guess I write E1 going this way, E2 going that way, and E3 going that way. They're all at 90 degrees. Okay. Words, formulas, pictures, looks good.